dear students, there is a question in JEE Advanced 2025 in this manner. So they are asking, by giving 4 different reactions, they are saying PQRS are the major products. So now out of this PQRS, the product having highest number of unsaturated carbon atoms. It means the carbon should be having like along with one sigma bond, there should be one pi bond should be there. So that is what, either carbon should be sp2 or sp hybridization it should be. If it is sp3, we can say saturated, right? If it is sp2 or sp, we are saying it is unsaturated. Now the one which is having the product one which is having maximum number of unsaturated carbons, we need to identify from these 4 options. It means the product formed in these 4 given reactions. Okay, so in order to answer this, we need to take this reaction one by one and we need to write the proper product for this every of this reaction. So let us understand the product formed in these reactions by taking each of these. Okay, so here I will be taking this reaction here and let us understand this. See, we have carboxylic acid and this position, see, this is alpha carbon, right? So here we have 2 hydrogen atoms, right? Now these hydrogen atoms, whenever we are treating with this carboxylic acid with alpha hydrogens, whenever we are treating with halogen in red phosphorus, so it will be giving alpha halogenated product. That is what HVZ we are studying now. Yes, so now followed by hydrolysis means this carboxylic acid will retains in the reaction. So let us understand that. So Br2 red phosphorus, whenever we are treating this halogen with Br2 to this substrate, so what happens here? So we will be getting a product something like this. So bromination here, okay, and CO Br like this, it will be changes. Okay, so but after this what we have, hydrolysis we have now, so it means this Br will remove and that will be replaced by OH group, so that we will be getting a final product like this, CO OH Br. So this is our product. Now how many carbons are unsaturated here? See, now here in this benzene ring, we know here we have triple bond, like 3 pi bonds like this. So all these 6 carbons are unsaturated, all are sp2 carbons only. So 6 carbons here plus, and this carbon is also sp2 which is having 1 pi bond along with the sigma bond. So this is 1. So total 7 carbons are sp2 in this particular reaction. Okay, so for P, product P, how many carbons are there? 7 carbons are sp2, I mean unsaturated carbons are there in the first option. So let us do it for second reaction also. So what is this reaction? Just look at the reaction here. I try to understand that. Look here, see, we have a benzaldehyde which is having 0 alpha hydrogen, but this is a acetaldehyde. To this is a alpha carbon having 3 hydrogens. So I can say this is alpha hydrogen containing carbonyl group with a dilute base. So it can undergo aldol condensation, right? Yes. So with the dilute base, we have alpha hydrogens here. Yes. So this will abstract this proton and makes one carbon anion that will be attached at this electrophilic site of this carbonyl group. Hope it is clear. So that is what cross aldol product formed in this reaction. So now what happens here? So whenever we are treating with alkali, I mean aqueous base, so that base will abstract this acidic proton. So this is 3 hydrogens are there now. From that, 1 acidic hydrogen is abstracted by this base and forming a carbon anion like this. Okay, so this is what we get. Okay, this carbon anion now acting as a nucleophile attacks at this benzaldehydic electrophilic carbon. This is the electrophilic carbon now. So there this carbon anion will attacks and this carbonyl groups becomes alcoholic group. Okay, so finally we are getting a aldol product something like this, CO minus H. Okay, to that what we have, CH2 COH. Hope it is clear how this product is formed, right? So this will be O minus as these pi electrons are moving upward towards the oxygen, right? So now see, in the first step it is abstracted proton now, so that proton is given back to this O minus, so that we are getting a OH group here. So this is what one aldehyde, see, to this aldehydic carbon, So to this aldehydic carbon, this is alpha carbon, this is beta carbon. So now we can say this product as beta hydroxycarbonyl compound, right? So now this is what beta hydroxycarbonyl compound upon heating. So upon heating what happens? Upon supplying some heat, what happens? Here we have acidic proton, alpha hydrogens which are to this carbonyl group are considered to be acidic protons, okay, that can be removed by the base because reaction is taking place in basic medium only. So that basic medium, that whatever the base is there, that will abstract one more proton from here. So that proton and this OH leave goes from here, eliminated as a water, and we will be getting a alpha beta unsaturated carbonyl compound, that is a final product here, okay. So here this OH group and here one H plus. So totally it is going as water and we are getting a double bond here, something like this. So this is a product formed in this reaction. See, to this carbon, this is alpha, this is beta. Alpha beta unsaturated carbonyl compound is our product in the aldol condensation. Okay, so this is about the reaction mechanism. Now you know there is a simple trick also. See, here we have acidic protons now. So remove these two acidic protons and this oxygen. Therefore make a double bond between this carbon and this carbon. Right. That's it. You will get a direct product like this. This is the simple trick you can follow. So now how many alpha like unsaturated carbons are there here? So these are six unsaturated carbons. All are sp2 hybridized, and this one also and this one also, because there is a pi bond here along with the sigma bond, right? So these are 2 carbons here and this is also one more carbon. So total 8 carbons. See, 6, 8, 9. So 9 carbons are unsaturated here. So in the option 2, in the question here it is given now, Q is having how many carbons now? It is having 9 carbons with sp2 hybridization. Hope it is clear. So that is what number of unsaturated carbons here is 9. Now you can also do it for option question like option number 3 here. So let us take this into the new slide so that we can discuss it without any confusions. Yeah. So here we have this question. So let us take this. So tell me here, so we have a alkyne group. See, this carbon having hydrogen now, alkyne carbon having hydrogen is acidic hydrogen. This is acidic hydrogen. So here we have a strong base also that will take that acidic hydrogen, NH2, sodamide we can say. So this Na plus NH2 minus, this NH2 minus abstract the proton and generates a carbene anion like this. Now these will be attacks on this allylic bromide. See, we have allyl bromide like this now. So you know these allyl carbocations are more stable now. So therefore this bromide ion is a good leaving group, goes out and resulting to form a carbocation like this. So this carbocation which is stabilized by this like this pi bonds by resonance like this, right now. So now on this carbocation, yes, the carbon anion will attack. So in organic chemistry, it is just simple. See, identifying electrophilic site and nucleophilic site and exact electrophilic site and exact nucleophilic site and making a bond between them is one of the major step in all the chemical reactions. See, this is a carbon, this is a bromine, and the carbon, see, bromine goes out and creates a positive charge here which is electrophilic site, on which this carbon anion which is a nucleophile attacking takes place. Therefore, we will be getting a product like this. Like this is our product. Hope it is clear. So now after doing this, see, up to here we are done. We also have some second step also, Hg plus 2 and water. So in this what happens, you know, see this Hg plus 2 is there now. So that will react with this triple bond, okay, and makes a 3-membered ring. So on that, water followed by attack of this water, so will generate something alcohol like this. After this we have water also, right? So now this generates something like this. Here OH group, okay. So to this one hydrogen will be attached, okay. So now see here what happens, we have all alcohol and double bond here. So keto-enol tautomerism, you know now. So that tautomerism takes place here. So like this, and this will goes here, okay. So finally we are getting a carbonyl group like this. Compound product is something like this. See, to this I am writing CH2 group, CH2, CH, double bond, CH2. Okay, so this is the product form. Now tell me how many carbons are unsaturated here. All the 6 carbons are sp2, so 6, and this is also having one pi bond, so that one carbon I am writing, and here 2 carbons, so 2. So totally again how many? 6 plus 1, 7 plus 2, 9. So 9 carbons are unsaturated here. So for option number 3 also, R is also having 9 carbons which are unsaturated. Now let us take this reaction which is from 4th. Yeah, so let us understand this reaction. See, ozonolysis. So whenever we are studying hydrocarbons, this ozonolysis no one should skip, right? Because it is one of the very important concept. So ozonolysis takes place at unsaturated site, but not on the exact benzene disposition. So it will be having only one ozone and H, one equivalent. Let us consider it as one equivalent, so that it will happens here. See, this double bond is there now, so just break it. Therefore, we will be getting a product like this. Like this I am writing. Okay, so it means for more clarity I am writing it in this manner. Yeah, here one aldehyde group, and this carbon, yes, this is another aldehyde. Okay, so now to this we are adding methyl magnesium bromide. So methyl magnesium bromide, it's Grignard reagent I can say, right? MgBr, so methyl negative charge, and this will be having positive charge for this side. Okay, so now this is strong nucleophile and having 2 equivalents, so both aldehyde group here and here both will be undergoing like nucleophilic attack like this here and here. Okay, so that we will be getting a alcoholic product something like this. O minus H, and here also H, this becomes O minus and methyl group. Okay, here also methyl is attacking takes place. Okay, so let us see at the question. Yes, so this is what we have taken, and you know in the question it is mentioned there is one methyl group here and the second position. Okay, so it means in our product also, see here also one methyl group should be there. Okay, so it means here also we have CH3 group. Okay, so here we have 2 CH3 groups. Fine, up to here it is done now. So in the final step what we have? Addition of H plus, acidic medium now. So just add H plus. So if we add H plus, what happens? This O minus groups are there now, converts into alcohols. So directly I am making this as alcohols. So to make one step less here, so H. So 2 alcoholic sites are generated. To this we are making dehydration, heating condition is mentioned. So now look here, so we can get a one product here. Look here, observe properly. We have alcohol here, and these are product hydrogen we have. See, to this benzene, here we have, if we remove H plus from here, OH minus from here, so we can get a product like this. Like this, right? So this is a unsaturated compound. So here also we can remove H plus from here and OH minus from here, and we can get a product like this. Now count how many unsaturated carbons are there? 6, 7, 8, 9, 10. So 10 are there. So which is having maximum number of unsaturation? So this is 10 now. So which is having maximum? So 4th one is having maximum number of carbons with unsaturation. So that is our option. So thank you for watching. If you like the content, please click on the like button. Thank you.